Welcome back, everyone. So this week we will be covering Chapter 2, the Research Enterprise in Psychology. So pretty much what Chapter 2 is all about is what is the scientific process, how do you conduct good research in psychology. So we'll cover the scientific process, a theory, different ways of conducting research, as well as we'll cover a bit of statistics, as well as ethics. If you've looked on Moodle, you'll see that instead of splitting it up, then I've posted the entirety of my Chapter 2 slides for you all, just so that you guys can kind of keep it all in one place. I'm thinking that's going to be easier for everyone going forward. If this is not the case, please let me know, but otherwise I'm going to continue to just post the whole chapter at a time. So let's get into research. So the first thing is kind of what is science, right? So science is really kind of like detective work. Maybe not quite that kind of detective work Detective Pikachu did, although great movie, I quite enjoyed it. But science is when something happens and we need to explain it, then we use science and research methods to go about figuring out what happened. So we have to search for the answer. So we're going to look at the obvious, so that's kind of things you can physically see, and then there's also some hidden answers. So those could be things going on in the mind, things you can't just see right away. And then once we think we have the answer, we need to test it against the facts to see if we actually do have the correct answer or if our kind of detective skills need some fine-tuning. So the main tool in a psychologist or any kind of scientist tool bag is the scientific process. So this is a 4 or 5 step process. Here I just kind of lay out the 4 main steps. I'll tell you what the 5th is later. But the first step is you identify a question. So the first thing you really ask yourself is, well, what do we want to learn about? Or what is the question we have that you want answering? From that, you form a hypothesis. So the hypothesis is kind of what's our specific prediction. So what do we think the answer to the question is? Step number 3 is we gather information. So we go about, we might conduct an experiment, we might just observe things, but whichever one it is, we're going to gather that information unbiased. So we're just going to gather everything, whether it fits our prediction or not. And then number 4 is we analyze the data. So we look at all that information we gathered and we see, okay, what is the answer? What can we conclude based on that information we gathered? Now the 5th step is if you're wrong or even if you're right, you kind of go back and you're able to ask another question. Like, why was that the way? Or, okay, we found out A, but what about B? So the scientific process is really a cycle. So you go 1 to 4, and then you usually jump back to number 1. So the scientific method or scientific process, what it does is it really helps to separate myths from theories. So a myth, doesn't really have any information or whatever. A myth is kind of like someone formed a hypothesis, but then they never tested it. Whereas a theory is something that has been tested. So really the scientific process, it definitely mainly started by physicists and chemists to determine the laws of the physical sciences, but we can also use it in psychology, and it's used in pretty much every type of science, whether it's a physical science or a humanities science, whatever. So even in arts psychology, we use it. In science psychology, we use it. Everyone uses the scientific process. So After we do the scientific process, we usually end up with a theory. So what is a theory? A theory is a plausible or scientifically accepted general principle or body of principles that offer an explanation to a phenomenon. So pretty much what that means is after the scientific process, you had your question, you formed a hypothesis, you gathered data, you analyzed the data, and you ended up with an answer. Now, once you have that answer, then you can turn that answer into, say, a theory. So if your data kind of supported the hypothesis, and you end up with, okay, this is what's happening. And then, so with your theory, you can also, that's where you go back from number 4 of the scientific process back to number 1, where you can form more questions and more hypotheses from your theory. And so that's why we have multiple different theories in all types of sciences. And we'll talk about some theories throughout the course. So now, what makes a good theory? Because obviously there's some bad theories, and then there's good theories. So a good theory needs to organize information in a meaningful way. A good theory also needs to be testable. In other words, it's disprovable. In other words, if you keep testing it, there's always a possibility that you could prove it wrong. That's not to say that it is wrong, but it means that you can still test it. So it's not just a wild guess in the air that's impossible to test. That would be kind of like more of a myth. You can't always test a myth. Whereas a theory, you're able to test it and either support it or not support it. Also, in a good theory, the predictions are always supported by research. In other words, when you're testing a theory, then you can make predictions based on previous research. And then also a good theory always conforms to the law of parsimony. So the law of parsimony is very similar to Occam's razor. So Occam's razor is just saying that the simplest explanation is the right explanation. So if there's multiple explanations for something, whatever's the simplest, that's the one you're going to go with. So really that good theory that we always want, it really incorporates existing facts and observations. It helps to generate new hypotheses and predictions, and it also will always support the idea that if you have two theories to explain a certain phenomenon or a certain question, then you're always going to prefer that simpler theory. Okay. So let's kind of go through this, go through the steps again. So when I go through it here, I'm going to be talking about we're going to be talking about the bystander effect. So pretty much I'm going to tell not a fun story. I'm going to tell you a story, and then we're going to try to figure out what's happening. So there's this very famous incident that happened back in last century. I think it was the 70s. It might have been the 60s. But there's this woman, Kitty Genovese, and she was murdered. So what happened was she was walking home. She was at her apartment complex. A man attacks her. She's yelling for help. People can hear her. A man attacks her. He runs away because she keeps yelling. She's yelling for people to call 911. So he runs away. And then a couple minutes later, he comes back. So Kitty's still alive. She's getting back into her apartment. The man comes back and attacks her a second time. She's still yelling for help. There's still lots of people around. Eventually, Kitty does die, and the man leaves again. So in all, this whole thing took over 30 minutes of Kitty yelling for help, and at no point did any of her neighbors or bypassers call for police or go offer help. Some neighbors did call police once they no longer heard anything happening, but why did no one help during the attack when, the police later interviewed the apartment building, the apartment complex, and multiple people admitted they heard stuff or they watched from their window, but no one did anything. So this is our question. So step 1 in the scientific process is our question. So our question is, why did no one help? Right? So Kitty was yelling for help. Multiple people heard her. Why did no one help? So step 2 is we're going to form a hypothesis. So our hypothesis is that perhaps there was a diffusion of responsibility. In other words, people were like, oh, well, I'm sure someone else called, so I won't, because I don't want to overwhelm the police or something, right? So that was the hypothesis that some scientists at the time actually came up with. And so their hypothesis, which is usually formed in an if-then statement, their hypothesis was if multiple bystanders are present, then a diffusion of responsibility will decrease by each bystander's likelihood of intervening. In other words, the more people that are around, the less likely someone is to call police because they expect someone else would have. So then they're going to test the hypothesis. So obviously we don't want to, actually hurt people. So they needed to find a way to safely test this hypothesis. So they wanted to manipulate people. So they created an emergency in a controlled setting. Here what they did, they brought people into a, just like an office building. So they either had a small number of people, like say 3 people, or a large number of people, say 10, in an office building, sitting in the same room, and then they pumped smoke into it to make it look like there was a fire. And what they did was they looked at whether or not people went for help, as well as how quickly each participant went to help. So they then analyzed the data, so that's step 4. So they looked at all the numbers they gathered during their testing, and they looked at what it means. And then they're going to report their findings. And usually when we report our findings, we write it up and put it in an article in a peer-published journal. So what they found was that helping decreased as the perceived number of bystanders increased. In other words, the more people that there were in the room, the less likely an individual was to go seek help. So then from that we can build. So number 5, we can build. So we can either build a theory, or we can build on that by asking further questions and going back to number 1. So we could ask, well, what if, there were children involved? Or what if it was someone they knew versus someone they didn't know? That kind of thing. So that's how you build on your conclusions from your testing. And if you want to know more about this, there are lots of great videos about it on YouTube, or you can just Google the Kitty Genovese murder, and there's like a whole Wikipedia page on it as well. So it's very interesting, but also sad. Okay, so the problem that some researchers have actually found is studying humans themselves. And that's because it's really hard to understand humans because you can't observe someone's mental process, right? You can't see inside their head and see exactly how things are working and how someone gets from A to Z. They could go through the alphabet how it is, they could be skipping, you don't know. So when you're studying humans, you have to take into account a few things. You have to take into complexity. So we actually have over 500 million neurons in the brain alone. So there's a lot of things happening, a lot of different connections. And then we've got variability. So every person is different. So if you observe, say, 10 people, you may think you understand, but then you move on to an 11th person and they could act extremely different. And that's just because of the variability between people. And then we have reactivity. So the reactions, people will act differently when they know they're observed versus when they're not observed. So really, you can even think of that as just yourself, how you act when you're around, say, family versus how you act at home or when you're on a job interview. People will react differently in different situations based on who is observing them. And then, of course, you have the whole problem of because the mental process is unobservable, you have to then ask someone about the mental processes. And that could also, people might not always, understand what's happening with themselves, but then they also might not tell you exactly what's happening because they might not feel comfortable with that. And so when you have to talk to someone and say, how did that make you feel, or anything like that, then that's what we call hindsight understanding. So that means that you're trying to understand behavior by analyzing stuff after the fact. Okay, so hindsight means after the fact. So after viewing a behavior, you propose an explanation that makes sense in that context. So someone behaves a certain way, and then you can explain it away. Be like, oh, well, they were nervous, so that's why they acted like that. Rather than trying to explain behavior as it's happening or predict behavior. So we really are trying to understand behavior through hypothesis testing. And that way we can test the possible explanations through the scientific method, and we can really make sure that things are happening how we think it is, rather than having too much bias or kind of just creating more myths, and we actually get to test it so we have evidence to support our theories. So that's where we're going to stop it for this video. In the next video, we're going to talk about the different methods of research.